Hello everyone, my name is Spencer Sabatino, and today, on Spencer Study STEM, we'll be laying out a roadmap and a syllabus for my upcoming series on single variable calculus. So ultimately, this course will cover the concepts typically taught in a Calculus 1, Calculus 2 series of courses, so about 1 year's worth of material. And ultimately, I'm going to pack a majority of the essentials that's typically taught, including some things that are scarcely taught upon or maybe briefly mentioned and aren't typically went through due to time constraints. So my idea with this course is to cover all of Calculus 1, go into Calculus 2, and also touch on some side things that typically aren't talked about very much by common courses. So to start off with we'll start off with a roadmap, essentially, where we're going. So the first spot we're going to touch is we're actually going to talk about prerequisites. I can't spell, do not judge me. So ultimately, with prerequisites, we talk about concepts such as, can you do algebraic manipulation? If I give you an algebraic equation, are you able to solve for variables such as x or y? If you're given a system of equations, can you solve that? Can you ultimately use your skills that you've learned throughout Algebra 1, Algebra 2, and pre-calculus to solve an equation, whether it's a linear equation, a quadratic, a cubic, or any higher degree polynomial using methods that you've learned. Likewise, we will also talk about trigonometry. Trigonometry is very important, as we'll see recurrences of functions such as sines and cosines. And ultimately, you need to recall some key trig identities and some key trig values, as we'll come to learn, and we'll need to apply those when we see fit. Obviously, we'll have a video or two to go through algebra and trig, just make sure you remember how to use these concepts appropriately. So, after the prerequisites, after you've recalled most of your algebra, most of your trigonometry, the first place we will start with. This could be review for some, but we'll next talk about concepts of limits. So ultimately with limits, we'll talk about the formal definition, so typically called the epsilon delta definition of a limit. We'll touch on that. We'll find out how to solve limit problems with epsilon deltas. We'll be able to talk about how to informally solve a limit with the common definition of a limit. And likewise, we'll learn, we'll learn the utilities of the limit, and we'll learn how to solve limit expressions. So if I give you some function f of x, and I say find the limit as x approaches some value a of f of x, you're able to evaluate the limit, whether it be a numerical value, whether it be undefined, whether it be indeterminate, which you'll have to apply some techniques that we will recall from algebra and trig, luckily. And later we'll delve a little bit more on other ways of solving limits, but that will be saved for after we talk about our third idea, derivatives. So ultimately, with derivatives, once again, we'll talk about the definition of the derivative. So, there's the formal definition of the derivative that stems from the definition of the limit, and there's also the Newtonian definition of a derivative, as many of you will recall from the beginning of your Calculus 1 course, with the limit as h approaches 0 of f of x plus h minus f of x over h. Likewise, with derivatives, we'll learn about some very rudimentary ways of evaluating derivatives. So we'll talk about, tangent lines, everyone's favorite tangent lines. We'll talk about methods of taking derivatives, such as the power rule. We'll talk about the quotient rule, the product rule, and etc. We'll talk about all the various ways to allow us to take a derivative, whether or not we have a sum of functions, a product of functions, whatever function we have, ultimately we can take the derivative of it. Likewise, with derivatives, we obviously want to mention applications of the derivative. It's cool staring at a derivative, knowing how to take one, but where do derivatives come in? So we'll bring up some word problems, everyone's favorite type of problem. We'll bring in optimization. So if I give you a box of a specified area on perimeter, can you give me the max, or if I give you a box of a certain area, can you give me a maximum perimeter, or other common optimization problems? We'll also bring up applications through, say, the intermediate value theorem, and we'll also touch a little bit on L'Hopital's rule, which will allow us to evaluate some limits at some very unfavorable points. Likewise, after touching on the applications of a derivative, we'll come to integration. So integration, likewise, we'll obviously start with the definition of an integral. How would a mathematician define an integral then versus how would, say, an engineer or a student want to define an integral better? What about the definition? We'll talk about some common integrals. Can you take the integral of a polynomial? Can you take the integral of a basic trig function? And likewise, we'll also touch on numerical integrals. Apologies for the bad handwriting. Numerical integrals, and we'll also touch on the fundamental theorem of calculus, which will be the keystone of this section and arguably this course. Then we'll learn how to, likewise with integration, we will also learn how to evaluate integrals, obviously. We can apply what we learned with taking derivatives, see if we can use that with how we can take integrals. Well, section 6, chapter 6, we'll talk about integral applications. Likewise with the derivative, we can take integrals. That's cool, but how do we apply this? So we'll talk about volume of rotated figures or functions, I guess would be the best way to write it. We'll talk about that. We'll talk about the mean value theorem, which is one of the most important theorems in all of calculus and even analysis a little bit. Likewise, we'll also bring up some physics applications such as work and how to find the average value of a function. Ultimately, fairly important stuff. I'd say chapter 6 would probably be the hardest chapter of calculus 1. Next, with chapter 7, we'll talk about integration techniques, because as many of you, if you've ever taken a calculus course before, integration techniques can be, or integration as a whole, I should say, some integrals are easier than others. So we'll learn about hit integration techniques such as integration by parts. We'll talk about integration by partial fractions. We'll talk about integration using trig substitution. And likewise, we'll also talk about other common, trig identities that we can derive using, a myriad of these trig techniques, and also some previous trig identities or other integral techniques that we learned in chapter 5. such as mu substitutions, we'll learn a little bit as well, but that's a bit of a spoiler in my book. Lastly, for at least Calculus 1, Chapter 8, we'll talk about differential equations. Differential equations, optimally, we'll talk... Well, this will not be a full differential equations course. That will come down the line later. With differential equations, we'll talk about separable equations, we'll talk about some linear equations, and we'll talk about other fancy things such as Euler's method. Ultimately, I have to clarify, this list is not exhaustive. This list isn't... I'm not listing everything I'm going to talk about. I'm giving more or less the big points, the features of each chapter. Next, for Chapter 9, we'll delve a little bit onto different coordinate systems, such as polar and parametric, and how to use how to find various functions. Sorry, that's not writing. So, talk about polar and parametric coordinates. And ultimately, we'll learn how to write a function, and we'll learn how to write a function in polar or parametric coordinates. We'll use polar and parametric. We'll use these functions more or less. These writing of functions, polar, parametric. We'll use those to maybe simplify integrals that might otherwise be a little sketchy. And likewise, we'll talk about various concepts such as arc length, how to evaluate that if it's easier with polar or parametric coordinates. Next up on the list, we'll talk a little bit about infinite sequences and series. So ultimately, infinite sequences and series are probably the hardest section or hardest part of maybe all of single variable calculus, but especially of calculus 2, because this is arguably the most abstract of the sections. So with this, we'll recall definition of a sequence and a series. We'll talk about what it means to be convergent and divergent. And we'll also talk about all the various tests that we can use to test for convergence or divergence. So in the case of series, we have the p-series test, we have the integral test, and other common things. So we have those two tests, and at the end we'll talk about Taylor series, ultimately capping off the end of this 10-section course. So with this is the crux of what we'll be talking about. Starting from Chapter 1, going through Chapter 10, there shouldn't be any real flopping around or anything. We shouldn't be hopping from Chapter 1 subjects to Chapter 6. I think the only real time you could say I'm arguably jumping around would be with, we talk about applications of derivative. We mentioned L'Hopital's rule. L'Hopital's rule does extend a little bit of Chapter 2 concepts with, limits, being able to evaluate some limits again. But ultimately, that's one thing you should expect from this course, is that things from previous chapters will come up occasionally in later material. There's no guarantee that you'll be using, algebra all the time, especially when you get toward the end, when you start touching around with sequences and series, and it's more or less just finding what test you need to use. There's no guarantee that derivatives will show up there in Chapter 11 or Chapter 10, but I'd say don't be surprised if something shows up from a previous chapter. This is a course after all, it's cumulative. So with that, I'll leave you with this video, and I'll see you in the next one.